Morning, Kayla. Um, as you see, I have listed on the board number one, all the way in that right-hand corner, a important reminder or piece of news, if it's not new to you, that we are up to having our first quiz. Some of our quizzes are going to be on Delta Math. This first one is. Some of our quizzes and tests will be on Blackboard. The midterm and final will be on Blackboard, but there might be one or two tests on Blackboard as well. But this first quiz is going to be on Delta Math. If you haven't signed into Delta Math and gotten yourself set up in our class, you must do that. The quiz will be available, I think, probably right after class today, starting today until Friday, the 16th of September, this Friday, for full credit. Once you start the quiz, you must complete it in one sitting. You have an option when to start it any place, but make sure you finish it before the due date, which you'll see listed when you open up your Delta Math. If you miss the due date, you can take it for reduced credit. You will not get full credit for it if you take it after the due date, but you will get most of the credit, so you really should do it. So that's the quiz that we're going to have. Today, the first part of our lesson is going to be a review for that quiz. There are going to be a total of 10 questions on the quiz. You'll have 45 minutes, which is more than sufficient to do the quiz. And we're going to go through different questions that are similar to what are going to be on that quiz. And in some cases, I'm going to mention how you should go about putting your answers in on the Delta Math. A couple of people have asked me questions about it. Of course, you can always ask me a question, but it makes sense to practice this before you actually go to the quiz, because once you go to the quiz, if you close the Delta Math quiz, it's going to submit. If you have any problems, like it submits early because you didn't realize, you can always ask me, you can email me, I can reopen it, but that's only if you have a problem. This is true also for any test that you take online. If you run into problems, you email me and I try to fix the problem. I can't always fix it, but I usually can help you in some way or other. Okay, so I'm giving you, there are 3 problems listed so far on the board. These are all review problems on solving equations, solving linear equations. I'm giving you a few minutes to work on this, and then we'll do them together. If you have an answer, either tell me the answer or you can post it on the chat, either for everybody or just send it to me personally if you want to do it that way. Okay, so here I'm giving you, it's now 8:25, so I'm going to give you until 8:30 to work on these. Okay. Okay, I see a couple of people. Kayla, thank you. You sent me all three answers. Let's see if they came out correct. I see some other people have also sent in answers. Let's work on these and talk about how we would do this if we were doing this on Delta Math in terms of submitting an answer. Because as I said, your first quiz is going to be on Delta Math. Okay, so let's look at this first example. It says x over 3 minus 31 equals negative 29. And obviously, we want to isolate the x. So the first step I would do is I would try to get rid of this negative 31 by adding 31 to both sides. Which gives me the x over 3 equals negative 29 plus 31, which is 2. Now, if you recall what I said, when you have fractions, it's a good idea to have everything written as a fraction. So let's write this as 2 over 1, so that we keep in mind that the 2 is really in the numerator. When you have a whole number, it really means that number is in the numerator, and the number and there's no denominator. It's understood the denominator is 1. And we see that our common denominator here is 3. So what we're going to do now is take that 3, put it over 1, the common denominator is 3, put over 1, and we're going to multiply both sides of the equation by this 3 over 1. Remember, whenever we're solving an equation, we're attempting to maintain a balance. The two things are equal, that means they're balanced. So whenever we do something to one side, we've got to do the exact same thing to the other side to maintain that balance. In this case, we're going to be multiplying by 3/1. So going over here, we'll get 3/1 times x over 3 equals 3/1 times 2/1. I distributed this 3 to all the terms. Now here, the 3 on top cancels out with the 3 on the bottom, which leaves me just 1x or x. On the other side, we have nothing to cancel out because the denominators are already 1. So we do 3 times 2 and we get 6. So your final answer is 6. When you do a problem like this, of course, you don't have to show all these steps. You could have probably done some of this in your head if you wanted to. In terms of solving an equation, when you solve an equation on Delta Math, the only thing you're to type in is the answer. In other words, when you go to submit, you put in 6. Don't put x equals 6. They don't want that. They just want the 6. So you put in the 6 and put submit answer, and it'll tell you if your answer is right or wrong. On the quiz, each of the questions will have, you'll get 2 chances to get it right. So if you get it wrong the first time, you can redo it and still get full credit for it. Okay, so that takes care of question number 1. So now let's look at question number 2. We have 6 parentheses x minus 14 equals 6. So our standard method when we have a parentheses in an equation is to get rid of the parentheses by distributing. So 6 times x is 6x. 6 times 14 is 84. Okay, our next step is to isolate the variable, get the x by itself. So what we're going to do is we're going to add 84 to both sides, which will give us 6x equals 6 plus 84, which is 90. Of course, for all this, you can be using your calculator. There is nobody saying on a Delta Math quiz that you can't use a calculator. You can. You're entitled to use a calculator. As I said, I don't want you using a graphing calculator. I want you using a standard 2-line scientific calculator. Again, if you have any questions about it, you can either ask me later in the class, or you can send me a text with a picture of your calculator, and I'll tell you if it's an appropriate calculator for this class. If you are just buying a calculator now, just don't open the package. Keep your receipt. Don't open the package. Send me a picture. I'll tell you if I like it or if you're going to like it, because there are certain calculators that are much more user-friendly than others, and you want to have one that's going to make it easy for you to work. Okay, going back to this, we now have to divide everything by the 6, and 90 divided by 6 is 15. So our answer in this case is 15. Again, on your Delta Math, all you do is put in the 15. So I think, Kayla, so far you're 2 out of 2. Let's see if you're okay, got the right answer on the last one as well. The last question, it looks a little bit more complicated because it's just more to do. But again, if you notice, I sort of gave these as easy, a little bit harder because we had a parentheses, a little bit harder now. So, but again, we're going to be solving this equation by first removing the parentheses, collecting the like terms, and then getting all the x's on the left and all the numbers on the right. So first, let's multiply by the 2 on the outside here. It's 10x minus 4. Don't forget, be careful with your signs. If there's no sign, it means it's positive. If there is a sign, if there's a minus sign, don't forget to include that minus sign when you're multiplying. If there's just a negative sign in, or a minus sign in front of a parentheses, just put if there's an imaginary 1 there. So just remember, that negative means really -1, and multiply everything by -1. We don't have that right here. Now there's nothing to move here, so I'm just continuing this. So now we have 10x minus 4 minus 2x minus 2 equals 34. So before I start moving things, let's collect the like terms. So here we have the 10x. Here we have minus 2x. So 10x minus 2x gives us 8x. Now we have a -4 and a -2. Be very careful. -4 minus 2. You could just type it into your calculator. But remember, if you're putting in -4, if you're starting, don't start with the subtraction sign. This is a -4 minus 2, which gives you -6 equals 34. We'll then add 6 to both sides. So we'll get 8x equals 40. And dividing both sides by 8, we get as our final answer 5. And I think, Kayla, I think you got that 5 also. Thank you, Kayla, for sending me the answers. I'd like to see answers from other people as well. So that is, again, for question number 1, you just submit 6. For question number 2, you just submit 15. For question number 3, you would just submit 5. Okay, so let's continue from here with our review. So the next questions I'm going to put we're going to have a few questions that have to do with inequality. Okay, as a reminder, we are now doing review for our first quiz on Delta Math. These first few questions were a review of solving linear equations. We're now going into linear inequalities. And again, these are specifically, since we're doing this as a review for that quiz, I'm giving hints as to what to do when you get to the Delta Math. Okay, so I'm going to put a couple of problems on the board and give you some time to do it. This was question number 4. 8x minus 3 is greater than 4x plus 5. I want you to solve that as an inequality. And give your answer as an inequality. Okay, so solve that. And question number 5 is just an inequality. We want to graph this on the number line. Okay, I'm going to give you a few minutes to try that. I see some people have already answered number 1, so let's do number 1, with number 4. Let's do number 4, and then I'll give you a couple more minutes to do number 5. Okay. Remember, we solve inequalities the same way we solve equations. We get the x's to one side, specifically to the left side, the numbers to the right side. Okay, so I'm going to first subtract 4x from both sides, which will give me 8x minus 4x, which is 4x, minus 3 greater than 5. I'll then add 3 to both sides. So we get 4x greater than 8. And remember, all this time, we make sure that we keep the direction of the inequality the same. And then we're going to divide by 4. Remember, we're dividing by a positive number. We divide by a positive number, 4x divided by 4 is greater than 8. And then since we divide by a positive number, we're going to get x greater than 2. We don't change the direction of the inequality because we are dividing by a positive number. Hint, when you go to my, if anybody's having trouble seeing me, try and pin me to your board. How do you do that? You go to my picture and click on my picture. There should be 3 little dots there. And one of the things will say pin. What pin means that you are keeping my picture on the board. That's what I try to do. I try to keep myself pinned so I can see only me, because otherwise, because I need on the recording, I need me to be seen and not other people, unless the other person is speaking. So try doing that. Is that working for you? Okay, let's go back to this. Our solution, because they just asked us to solve it, is x greater than 2. Now, how do you put in, when you solve an inequality, you can't just put in the 2. You have to actually type x, and then there's a little box there that has a less than sign with if you notice, there's like a little V dot. Click on this, and then click on that line going down so that it goes, if you can pick this one. You don't want this one. You want to pick this one, and then you type in your 2. Your final answer should say not just 2, but it should say x greater than 2. That's on the delta math. When you're solving an inequality, you must put in the inequality sign as well. And they give you their options there. If you look at their options, you will see that there's an option for an inequality. Just click on that little down arrow to pick the one that you want. Okay, looking at the second one, all I ask you is to graph on a number line x less than or equal to 11. So let's remember how we do this. We're going to go to 11 on the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's 11. Since it says less than or equal to, we want a filled in circle. And the arrow of the inequality is pointing to the left. So therefore, we have an arrow going to the left. This is what you should be graphing on the number line. How do you do that on Delta Math? You go to your left on 11 on the number line that they provide, and you click on it and then drag. So you get an arrow from the 11 pointing to the left. Notice the default will always be a filled in circle at the number that you clicked. If for some reason you don't want a filled in circle, you've got to click on that dot. This is after you put in the arrow, click on that, and it changes the filled in circle to an open circle. If you want to fill it, decide you really wanted it a filled in circle, just click on it again. So that's how you would answer it on Delta Math, and this is what it should show. Okay. Any questions? Okay, so let's now go on to another couple of questions on inequalities. Again, I'm going to give you a couple minutes to try it, and then we'll do it together. So what if I gave you what's this kind of inequality? It's I want you to solve this inequality. And I want you, which means I want you to do two things. I want you to solve, and I want you to put your answer on the number line. Okay, so that's number 6. Number 7 that we're doing is, I'm going to give you a picture and I want you to write this in interval notation. It's an arrow from the -2 to the filled in circle here, going to the left. Let me redraw this. Unclear right now. Give a couple minutes to try this. So this is an interval notation. Thank you, Isis. Okay, let's see if we can work this out together. Get a couple of people answering me. Let's see if we can do that. Okay, so in order to solve inequality, again, we remember we work it like an equation. What we're going to do is we're going to get the x alone on the left side. This will give us negative 3x less than 4 minus 7, which is negative 3. And that means I have to divide everything by negative 3. Now, this is where we're going to have to be very careful. Don't forget, when you're solving an inequality, if you divide by a negative number, it switches the direction of the inequality. So this will give us x greater than negative 3 divided by negative 3, x greater than 1. And I see a couple of people. Yes, thank you. Isis, Kayla, those were good answers. Okay. Remember, when you write your answer on a test, but even and also on Delta Math, you can't just write the one. You have to type in X, you have to pick the greater than symbol and put in 1. It asks for this in case if you're asked to put this on the number line. Remember, on your number line, here's your number line, you go to the number 1 and you click on 1. And what's going to happen is you're going to get a dot there. And then you know your arrow is pointing to the right. So you want to drag this to the right. And then, but this, remember, it'll come out first as a filled in circle. You're going to click it again so that you'll get an open circle, because the filled in circle is when you have greater than or equal to. This is the open circle, which is just greater than. So you need an open circle with an arrow from it going to the right. Remember, you draw the arrow first and then you click on the point to if it's filled in and you don't want it filled in. Question number 2. Question on the board now, which is question number 7. We have a graph with a filled in circle at -2 and an arrow going to the left. And they want me to put this answer in interval notation. So remember, when you're doing interval notation, you've always got to start at the left as your first point, and the second number is always the point on the right. Now, when you have an arrow pointing all the way to the left, it means that your starting point is -infinity. You're starting all the way at the left, so you must put that -infinity in first. And they give you options to put in parentheses, brackets, and they even give you options for the infinity sign. So anytime you have an infinity sign, whether it's positive or negative, you use a regular parentheses, type in your minus sign, and click on the infinity. Put a comma and then put in your -2. Type in -2. Now, since this was a filled-in circle, we want this to be a bracket. Pick the bracket, not the parentheses. The bracket is for the filled-in circle, the parentheses is for the open circle. So this is what it should look like as your answer in interval notation. Okay, let's continue with this. Here is question number 8. This is a compound inequality, and I want you to solve it and put the answer on the number line. So this is -3 less than 2x plus 3 less than or equal to 5. I want you to solve this and put it on the number line. Okay, and after we finish this one, I will do 2 questions on absolute values, which is the last topic. Give you a couple minutes to solve this compound inequality. Okay, let's do this together. Remember that this is the case where we have 2 inequalities in the same example. It's called a compound inequality, and what we want to do is get the x alone in the middle. This is really indicating 2 different inequalities, the way we solve it is by solving it as if it was a single inequality on both sides. So our objective is to get just X alone in the middle. Remember, we're doing two things at once, so whatever we do in the middle, we've got to do at either end, because it's as if we're solving this inequality without the less than or equal 5, and this inequality without the -3 less than. So, but since we have to do the same thing to both of them, it's much more efficient to do it as one problem, working to get the X alone in the middle. So the first thing I'm going to do is I'm going to -3, because I want, again, I'm looking to get that X alone. That means I have to -3 on the left side and on the right side. So here we're going to get -3 and -3, which together combine to -6. This is less than 2x. Remember, all we're doing is subtracting a 3, so we don't change the direction of the inequality. And here I'm doing 5 minus 3, which is giving me 2. Again, whatever I did in the middle, I did on either end. Now I go back to my middle. I see that I have an 2x, and what I want is just an x. I'm going to divide by 2. But again, if I divide by 2 in the middle, I've got to divide by 2 on either end. On whatever I do in the middle, I do at both ends. Don't forget that. That's the most common thing people forget. So -6 divided by 2 is -3. This stays less than because we divided by a positive number. We're not changing the direction of our inequality. This becomes X. And this is 2 divided by 2, which gives me less than or equal to 1. Again, my objective has been achieved. I've gotten my final answer. This is red. Well, if you're reading it in a line, this is -3 is less than X is less than or equal to 1, which means that the X is greater than the -3. And at the same time, it's less than or equal to 1. This is a double inequality, a compound inequality. It's telling us two things. I ask you to put this on the number line as well. So how would we go about putting this on a number line? So here's our -3, and here's our 1. This is really could be written, or not necessarily written, but expressed as X is between -3 and 1. That's why this is so efficient. When we're doing the compound inequality, we always have the smaller number on the left, the larger number on the right. And this X in the middle indicates that what we're indicating, what we want as our answer, is everything between the -3 and 1. Which means when I go to my number line, I'm going to want an open circle at -3, a filled-in circle at 1, because this is just a less than sign, but this is a less than or equals to, and a line in between. This is what your number line should look like. If you're doing this on Delta Math, you go to your number line on the answer, click on -3, drag it, and then click on 1. So that'll start off with a filled-in circle at -3 and a line going to 1 and a filled in circle at 1. You're then going to have to go back to the -3 and click it again so that you get the open circle. That's how you would do this on Delta Math. Any question about this? If you had wanted to write this, they didn't ask it, but if you had wanted to write this in integral notation, then what you would have done is you would have put the -3 as your point that's on the left. You would have put the 1 on the second number as the point number on the right. And you would have had to put in parentheses. You'd have to put a regular parentheses at -3 to show that the -3 is not included, but a bracket at the 1 to show that the 1 is included. Remember, the regular parentheses is equivalent to an open circle. The bracket is where you have the filled in circle. So you could, if you were asked to give the answer in integral notation, this is the way you would have given the answer. They didn't, they asked me just for this, but this is how you would have had to put in your answer, -3, click on the less than sign, X, click on the less than or equal sign, 1, type in 1. And this is how you would, your graph would look on the Delta Math. Okay, let's go on from here. We have 2 more questions that I want to do. These are questions that have to do with absolute value equations, so let's do those. And question number 9 looks like this. Okay, we want to solve these. Number 1 is the absolute value of -6 plus 2x equals 7. That's the number 9. And number 10 looks like this. The absolute value of 10 minus 2x equals absolute value minus 1 equals 9. Okay, I'm going to give you time to solve these 2 absolute value questions, and in the interim, I'm going to be taking attendance. Olivia, Isis.
Here.
Hi, good morning.
Good morning.
Elvaro Blake. Lewis Hart Kayola. Emma.
Hey, Professor. I'm here, Professor. I stepped out of the room really fast.
Okay, got you. Demetrius.
Here.
Hi, good morning. Desmond Fleming. Shania Haley. Shania. Caden Harris. Kayla Harris. I know you're here, Kayla, because you've been answering all my questions. Sanjita Hussain. Sanjita? Oriana Jonas?
Yes, I'm here.
Yeah, I know you're here. Okay.
You said Anaya Sims?
Not yet. Sims is towards the end of the, but you don't have to answer. I won't call you anymore. I'm marking you. Now I'm making you here.
Okay, thank you.
Tahira Joseph. Tahira,
I'm here.
good morning. Michaela Martinez.
Here.
I know you're here because you were here right at the beginning. Thanks. Kiana Perez. Kiana. Carleaf. Hi, good morning. Jenna Pierre.
I'm here.
Hi, good morning. Tatiana Sanchez.
Here.
Good morning. Kazan Small.
Morning, Professor. I'm here.
Oh, good morning. Nice to hear your voice. Trina Small. Trina. Hi, good morning. And Jean Thomas.
Hi, thank you for that. I'm so sorry about the delay. We're gonna get started here. Apologies about that.
Okay, Elvaro, I see you're here. Somebody has signed in on Zoom as iPhone. Now, I usually use the participant list to figure out who's in class if I missed anybody on attendance. So I don't know who iPhone is. So don't come on as iPhone, come on as your name. It's much better. Is there anybody that did not hear their name called? right? Okay. Let's do these problems now. Remember, and this is extremely important, because if you don't do this, you're gonna get the problem wrong. Whenever you have these two lines on the side of a problem, that means absolute value, and you must get two equations out of the question, and you have to solve it twice and get two answers. So we change this to we make sure that the absolute value is by itself, which it is, and then we change it to -6 plus 2x equals 7 for our first equation. In other words, just dropping those absolute values. Your second equation is the -6 plus 2x has to equal -7. I forgot to remind you that the first thing you do before you start solving it is you make sure the absolute value is equal to a positive number. Because if it's equal to a negative number, that doesn't make sense. That's not what the meaning of absolute value is, and therefore there can be no solution. There's only a solution if this is a positive number, and then there are going to be two solutions. Now we solve this equation twice. Add 6 to both sides will give us 2x equals 13. Divided by 2. So our answer, one answer is 13/2. And you do not have to change it to a decimal. You can leave it as what we call an improper fraction, 13/2. Your second answer, we add 6 to both sides, and we get 2x equals -1. And we divide by 2, and my second answer is -0.5. So you've got to put in both of these answers. So the question is on Delta Math, how do you put in that answer? So where it says submit answer, all the way on the left, there's a little plus, there's a plus and a minus button. It's pretty small, but look, there's some other things there. But when you click on the plus button, again, you're looking all the way on the right where it says submit answer. If you click on the plus button, what it pops up is something like this, what we call a braces, this fancy curly Q parentheses. a box, a parentheses, a box, and again, the close of that. In other words, wherever you have a question that you want to put into answers, you have to indicate to Delta Math that you want to put into answers by clicking on that plus button. And then one of these, you're going to type in 13 slash, the forward slash is the symbol that they use for division 2. In your second parentheses, you're going to, in your second box, you're going to type in -1 / 2. This is what your answer should look like. And then, of course, you press submit answer. And that's how you put in 2 answers. And with an absolute value equation, you must have 2 answers. Okay, so your 2 answers were 13/2 and -1/2. And both answers are correct, and you must give both answers. Looking at this last question, which is number 10, the second one that's on the board, it's also an absolute value equation. We have to first add 1 to get the absolute value by itself. So therefore, we'll have the absolute value of 10 minus 2x equals 10. Again, I look at this number. If this was a negative number, I would, again, I look at it after I've gotten the absolute value isolated. If it's a negative number, stop right there, no solution. Okay, but this is positive, so we're going to divide it into 2 equations. 10 minus 2x equals 10 as one equation. 10 minus 2x equals -10 as our second equation. So your 2 equations come by taking the positive number and then taking this as a negative number. Okay, and we solve. So first of all, I subtract 10 from both sides over here. Gives me -10x equals 10 minus 10 is 0. Divide by -2. And my answer is 0. My second equation, I do the same thing. I subtract 10 from both sides. Now I get -2x equals -10 minus 10 is -20. Again, if you're not getting these, if you're making mistakes on getting the numbers right, use your calculator. You're allowed to use the calculator. Dividing by -2 gives us x equal to 10 as our second. Again, we have to click on that plus button so that we are able to have 2 solutions. And when one will put in 0 and then one will put in 10. Again, it doesn't matter which number you put first or second. This is not a number line. It's not interval notation. It's just an indication of 2 answers. Okay, that is pretty much a review for the Delta Math quiz that is going to, you can take it anytime from now until you have to finish it by September 16th, which is Friday. You have to find some time. It's not an in-class test. It happens to be a quiz that you do on Delta Math. If you want full credit, you have to do it by Friday. Make sure to check on it. Make sure you're up to date with your Delta Math homeworks. There is one that was due today, which covered this material. There's one that's going to be due on Wednesday, which is, again, I would do the homeworks first before I take the quiz. So I'm sure that you have a lot of practice in using the Delta Math program. Okay. We now have about a half an hour left to class. So I'm going to go back to what we were talking about on Friday, which is the start of chapter 2. Chapter 2 is graphing of linear equations. And we started talking about how we go about graphing a linear equation. What you should be looking, I'll mention this right now. If you look on your Blackboard account, you will see that one of the sections in our Math 136 class is something called weekly folder. If you click on the weekly folder section, you will see that each week I'm indicating what's going to be taught that week. Now, sometimes I'm a little bit off on my weeks, so I say it's week 2 and it's really in week 3, but one of the things that's included in the weekly folder is a practice example sheet for that particular topic that we're doing that week. For example, this week we are going to be doing graphing linear equations. If you look at the practice example sheet, it looks something like this. You should be printing it out. It's about 24 different questions that are questions that came from the department that are pertinent to the topic. Not only does it have the questions, there's a second example sheet. It's not an example, it actually is an answer sheet. So there's a question sheet and an answer sheet for each topic. There was one on chapter 1 that was actually in weekly folder week number 2. What I'm working on now, and it's a good idea to have it in class because I do use the problem ones, is the practice example sheet from week 3. All right, so what did we talk about so far? We talked about 2 ways of taking the equation of a line and graphing it. One method was finding the intercepts of the line. I'm not going to review the plotting points method. I'm going to go and do review for the intercept method, and then we're going to talk about a third method, something called the slope intercept method. So let's take an equation that looks like this. 3y minus 5x equals 15. It's called a linear equation. Let's remind ourselves, we call it a linear equation because there are no exponents. Linear is sometimes called a first degree equation. The degree of the equation is the highest exponents you see on the variables. There are no exponents on these variables. This is really understood to be a one exponent. This is understood to be a 1 exponent. When you have an equation without any exponents, indicating that the exponents are 1, whether there's just an x, just a y, or an x and a y, those are what are called linear equations, and when we graph them, they give us lines. That's why they're called linear equations. So linear equations, sometimes they're called first degree equations too, because that indicates what the exponent is, but those terms are interchangeable. They mean the same thing. A linear equation is a first degree equation. A first degree equation is a linear equation. Okay, so we know this is a linear equation, which means on the graph, it should represent the line. How do we find the line that this represents? So number one method we said is by finding what are called the intercepts. Here's what our graph is going to look like. There's going to be a vertical and a horizontal axis. The horizontal line, the horizontal axis is called the x-axis. The vertical one, the one that goes up and down, is the y-axis. This point here is what we call the origin. The coordinate, each point on the graph is going to have two numbers called its coordinates, which tell you how to get to the point. The intercepts of the line, or of any graph, intercept means cross. There's a y-intercept, that means where is it crossing the y-axis. The x-intercept is where it's crossing the x-intercept. And here's the rule. To find the x-intercept, replace y in your equation with 0. Because when you're on the x, you're not going up, you're not going down. All the numbers, all the points on the x-axis have their y value being 0. If I replace y in this equation by 0, I'll get 3 times 0 minus 5x equals 15. Of course, 3 times 0 is 0, and 0 doesn't have to be put in, so this is just negative 5x equals 15. It's easy to find the intercept because you get an easy equation. It eliminates one of the variables. In this case, when you replace x with 0, you're not going to have when you replace the y with 0, you're not going to have any y, you're just going to have an x. In this case, we get x equals 15 divided by negative 5, which is negative 3. One way of saying this is to say that the x-intercept is negative 3. Or you could put it as a point. Remember, on the graph, every point has two numbers. In this case, the x is negative 3, and the y is 0. So I can either say my x-intercept is the point negative 3, 0, or I could use simpler language and just say the x-intercept is negative 3, which means on the x-axis, we go to negative 3 and we make a dot on the x-axis. Okay, now we remember our objective is to draw the line. So I have one point on the line, but one point is never enough to draw a line because you need to go, do I go this way? Do I go this way? Do I go this up and down? How do I go? Okay. So the next thing we do is find the y-intercept. Now, in order to find the y-intercept, we do just the opposite. To find the x-intercept, we replace the y with 0. To find the y-intercept, we have to replace the x with 0. Remember, the y-axis is right over here, which means all the points on the y-axis have to have their x equal to 0. They go neither left nor right. So that's why I put the x equal to 0. In the equation, if I put x equal to 0, I get 3y minus 5 times 0 equals 15. Again, anything with the 5 times 0 is 0. I don't have to put in the 0. This just means 3y equals 15. And that gives me y equaling 5. In other words, when we're talking about the y-intercept, the x is 0 and the y is 5. Again, I could just say the 5 is the y-intercept, but the more accurate way is to write it as a point 0, 5. What does that mean? It means on your y-axis, you go up to 5 and you make a point now. So the x-intercept was -3. The y-intercept was 5. The line must be the line that connects these points. So here's what our line goes. Notice I draw the line longer than beyond because it's a line, goes on and on endlessly. But this is a very efficient way of finding the how to draw the line if you have the equation of the line. Ruth, yes, have a good day. I see you have to leave.
Okay, thank you. I will email you about any question about the.
Okay, great. You can follow along on the, if you go to the recording, you could see the last few minutes because we're going to be finishing soon.
Okay, no problem. Thank you very much. Have a great day.
Have a good day. Okay, so this is what's called the intercept method of drawing the equation of the line. I wanted to start discussing another way of drawing the equation of a line. Again, we're starting out with an equation, a linear equation. We're trying to draw the line that is represented by this equation. There's this one-to-one relationship. A linear equation gives us a line. After we've done that, once we start with the equation, get the line, we're then going to go backwards and we're going to take a picture of a line and see if we can get to the equation. But before we do that, I want to go back. I'm going to start this whole problem again, showing you another method. So there will be actually 3 methods that we could use to graph the line from its equation. Again, the first method, which is plotting the points, we won't use too often, but it is a method. I will review this method, the first method, again on Wednesday. But let's look at this next method, which is called the slope intercept method. We sometimes talk about the equation of a line being what we call the y equals mx plus b4.
The slope intercept equation, would they be on the quiz?
No, what we're doing right now has nothing to do with the quiz. What the 10 questions that we did, that I went, those are the type of questions. This is
Okay.
chapter 2, and it's not on the quiz.
All right, thank you.
Okay. And we're going to go through this real thoroughly before I give you any quiz on it. Okay.
Yes, need that.
What does this mean? It means that if you have a linear equation, what you really could do is solve for y. Let's take this equation. 3y minus 5x equals 15. What does it mean, solve for y? It means get y equal to 1. And that's something that we often do with these equations. So in order to do this, you think about the y as being your variable, and everything else is like just a regular number. In other words, I want to get the y alone, which means the first thing I want to do is add 5x to both sides.
Ain't no budget, man. Because Fletcher was like, she's spoiled bad. And he was like, no.
Can you mute yourself? Because we hear talking. Now, this will leave me the 3y over here. And this is a 15 plus a 5x. Now, 15 and 5x are not like terms, so I can't combine them. I can't say it's 20 or whatever. I have to keep the x and the number separately. They are unlike terms. So for our purposes, it makes much more sense to have the X term as the first number and the plain number, the constant, as a second term. So I'm going to write this as 5X plus 15. Again, that's because we want to get into this format of what we call y equals mx plus b. I'm almost there with this equation, but what I first have to do is get the y alone, which means I've got to divide by 3. Now, when I'm dividing by 3 on this side, I've got to divide everything by 3. So let's see what we're left with. This leaves us just the y. This I can't simplify, so I'm just going to write a 5 over 3x. And this 15 over 3 is 5. Notice how it is in this format. It's y equals something times x plus something. The number that's in front of the x, we call it the coefficient of the x, is what we call m, is what we call the slope of the line. In our particular case, the number that's in front of the x is 5 over 3. So our slope for this particular line is what we call is 5/3 or 5 over 3. Again, sometimes it's a whole number, sometimes it's a fraction. If there's no number, if it's just a plain x, of course, that means the slope is 1. Usually, if the slope is most useful when we want to graph, if it's in a fraction form. We're going to talk about y in a minute. So if your slope comes out to be 7, you write it as 7 over 1 when you want to use it for graphing purposes. The second number, the standalone number, is what we call the b. It's called, remember I said this is called the slope intercept. The b is the y-intercept. In this case, the standalone number was 5. Now, if you remember from before, when we did this problem with the intercepts, what we got was that the y-intercept was 5. Notice, then I had to do a whole process. The truth is that in this case, I can find the y-intercept if I simply put my answer in what we call slope-intercept form. Now I'm going to go over here and I'm going to show you. I'm not giving you any homework on this yet. This is good. We're going to continue with this on Wednesday, but I just want to show you the alternate method we could have used with this, putting the line in this format and using it to graph the line. What we do when we're using the slope-intercept format is we first go to the b. The b we said was 5. That's the y-intercept. Go on your y-axis 1, 2, 3, 4, 5. Remember, it's on the y-axis, it's not the x-axis, which immediately gives you a point on the line. Now, again, remember I said 1 point is not enough. You need a second point, at least one more point. A third point is helpful because that it makes sure that you're doing it correct. But you would need at least one more point. So that's where your slope comes in. I'm going to write it over here. In this case, our slope is 5 over 3. Slope is a fraction which we call rise over run. The slope tells us how we can go from one point on a line to another. The numerator, that's why we always want it as a fraction, because it gives us 2 directions. The numerator, the top, gives us the rise, how much to go up or down. If it's positive, it means go up. If it's negative, it means go down. The denominator, the bottom, is what we call the run. That tells us how much to go to the left or right. Usually when we have a negative fraction, we have the negative on top. Again, the run is positive to the right, negative to the left. So you need at least 1 point to start with, which we have. We have this point right over here, the y-intercept. To get to another point, I can use my slope. I can rise 5. That means go from this point, not from the origin, but from the y-intercept. Go up 5. 1, 2, 3, 4, 5. And run 3. That means go to the right. 1, 2, 3. That gives you an additional point on the line. Now, if you have this, I don't have this on graph paper. If I have this on graph paper, it really is sufficient. But I could have done, just to show you what you could also do, 5 over 3 could also be written as -5 over -3, because a negative over a negative is positive, which means instead of having gone up 5 and 3 to the right, I could go down 5. A run of -5 is going down 5. 1, 2, 3, 4, 5. And I could run -3, which means go to the left 3. 1, 2, 3, which gives me this point. Now, if you notice, these points all line up. Here's my line. And of course, you draw it longer. If you look at the line that we drew before, it's exactly the same line. So this is the third method of drawing taking the equation of the line and drawing the graph of the line. This is what we call the slope-intercept method. Now, this is my, if you ask me which method do I prefer, I actually prefer this method. This is where we're going to start off on Wednesday. We're going to be doing more of this graphing of linear equations and really discussing the whole concept of slope and how to find the slope, etc., and how we can use the slope, and talking about special kinds of lines like horizontal and vertical lines. Now, is there anybody who wants to ask me any kind of question? I'm going to stop the recording in any case at this point.